breaking news. At precisely 0241 UTC, a global alert rippled across observatories on 3 continents. Data streams from Chile, Hawaii, and the Canary Islands lit up simultaneously, all reporting the same impossible event. An interstellar object, designated 3I Atlas, had altered its trajectory just hours before its closest approach to Mars. Today, the impossible just happened. Moments ago, instruments designed to detect nothing more than passive ice and dust recorded energy fluctuations where none should exist. This changes everything we thought we knew about interstellar visitors. If you want continuous cosmic updates as this story unfolds, now is the moment to hit like, subscribe, and stay with us, because what we are witnessing tonight may redefine humanity's place in the universe. Only minutes after the alert, internal NASA channels escalated the event from routine monitoring to anomaly classification. Engineers paused automated systems. Astronomers stopped speaking mid-sentence. Because 3I Atlas was never supposed to do this. It was supposed to pass Mars silently, like every other dead comet before it. Instead, it behaved as if it noticed where it was. To understand why scientists are alarmed, we need to establish authority and scale. This observation is not coming from a single telescope or a fringe researcher. NASA's Jet Propulsion Laboratory in California confirmed the data within minutes. The European Space Agency cross-verified it using the Mars Express Orbiter. Spectral readings from the Atacama Large Millimeter Array in northern Chile matched infrared signatures captured by the James Webb Space Telescope, currently positioned nearly 1.5 million kilometers from Earth. Hubble's ultraviolet sensors were pulled off a scheduled observation to confirm the shift. Harvard's Center for Astrophysics, Caltech's Planetary Science Division, and the European Space Network all signed on to the same emergency call. When institutions that rarely agree reach consensus this quickly, it means something is profoundly wrong, or profoundly new. The object we call 3I Atlas was first detected months ago at the edge of the solar system, entering from interstellar space at a velocity exceeding 58 kilometers per second. Its hyperbolic trajectory confirmed it was not bound to our sun. At the time, it appeared unremarkable, a faint, elongated body roughly 800 meters across, colder than 30 Kelvin, reflecting light like aged carbon ice. No coma, no tail, no activity. Just another cosmic drifter. But tonight, as it approaches within 0.48 astronomical units of Mars, its behavior changed. 48 hours before the event, trajectory models predicted a clean flyby. Gravitational perturbation from Mars would be negligible, less than a fraction of a millimeter per second in change in velocity. 11 hours later, a minor discrepancy appeared. The object was ahead of schedule by 0.03 seconds, within error margins, scientists said. 6 hours after that, the discrepancy grew. By 3 hours before closest approach, 3I Atlas had accelerated by an additional 0.9 meters per second. That may sound insignificant. It is not. At interplanetary scales, no natural process could produce such a precise directional acceleration without visible outgassing. Then came the color shift. Spectroscopy from JWST showed a sudden change in reflected wavelengths, from deep red carbon signatures to a narrow band of near-infrared emission centered at 1.65 microns. That band does not correspond to water, carbon dioxide, methane, or ammonia. It corresponds to nothing known in cometary physics. Temperature readings rose sharply from 31 Kelvin to 86 Kelvin under 12 minutes, without any increase in solar exposure. No tail formed, no debris cloud appeared. The object remained silent and intact. At 0217 UTC, just 24 minutes before Mars' closest approach, Mars Express detected a localized electromagnetic disturbance measured at 0.7 nanoteslas, synchronized perfectly with a pulse from 3I Atlas. The pulse repeated every 11.6 seconds, then 11.6 again and again. Perfectly regular. I remember staring at the data feed when that number stabilized. Random processes do not keep time. As the object passed Mars at a distance of 114,000 kilometers, closer than many satellites orbit Earth, high-resolution imaging revealed something else. Its silhouette was no longer irregular. The long-axis asymmetry flattened, edges sharpened. What had once looked like a tumbling shard now appeared controlled. Not smooth, not polished, but deliberate, as if internal forces were redistributing mass in real time. Within minutes, NASA convened an emergency scientific review. Dr. Elena Kovac at ESA's Planetary Defense Office ran rapid gravitational models. They showed thrust, low-level, continuous thrust equivalent to roughly 0.02 newtons. Tiny, but sustained, enough to explain the acceleration, enough to defy every known natural mechanism.
Could be triggering exotic outgassing, hydrogen trapped in amorphous ice perhaps. Dr. Marcus Reed at Caltech argued that interstellar objects might contain volatile compounds never before observed, releasing energy in unfamiliar ways. Simulations were run. They failed. The thrust vector was too unaligned, the pulse timing too precise, the spectral signature too narrow. The alternative hypothesis was voiced quietly at first, then louder. What if 3I Atlas is not purely natural, not a machine in the cinematic sense, but something engineered, or at least altered? Harvard researcher Dr. Samuel LaRue presented a model showing that a thin, dense internal structure could survive interstellar travel and activate only under specific gravitational conditions. Mars, with its weak magnetic field and iron-rich core, could be a trigger. Then the second wave hit. At 0249 UTC, 8 minutes after closest approach, one fragment separated from 3I Atlas, not explosively, cleanly. It drifted away at exactly 3.14 meters per second relative velocity. Pi. A coincidence, some said, but before debate could begin, the fragment vanished. Not dimmed, not obscured, it disappeared across optical, infrared, and radar simultaneously. Every sensor went dark, as if it had stepped out of space-time. At the same moment, satellites in Mars orbit reported brief communication dropouts. On Earth, deep space radio arrays experienced a half-second phase shift. Amateur radio operators in Australia reported static bursts at precisely the same interval as the earlier pulses. 11.6 seconds. This was no longer random. It was responding. Inside control rooms, conversations stopped being recorded. Encrypted channels lit up. Governments were notified, not with panic, but with urgency. NASA issued a classified advisory. ESA suspended public briefings. The phrase non-standard object behavior appeared in internal documents. I've seen that phrase before. It is never used lightly. On Earth, the effects were subtle. GPS satellites corrected for unexplained timing drift. Migratory bird tracking systems showed minor deviations over Eastern Europe. A magnetometer in Alaska recorded a transient anomaly, barely above background noise, but perfectly synchronized with the last detected pulse from 3I Atlas. And then, silence. As I speak now, 3I Atlas is moving away from Mars, its velocity stabilized, its emissions gone. It looks inert again, dead, like nothing happened. But the data remains immutable, unprecedented. This is the moment where science slows down and reflects. Maybe we are not witnessing an invasion or a message. Maybe we are witnessing technology so old, so patient, that it only reacts when conditions are right. Or maybe this is something even stranger, a form of physics we have not yet imagined, briefly revealed as it brushed past a neighboring world. For centuries, we believed the universe was indifferent. Tonight, that assumption feels less certain. When an object from another star system changes course near Mars, sheds a fragment, emits precise pulses, and then goes quiet, we are left with questions, not answers. And the most chilling question is this: if 3I Atlas reacted to Mars, what will it do when it reaches its next encounter? Because, according to updated projections, its trajectory will bring it closer to Earth's orbital plane than previously calculated. And whatever this object is, it is no longer behaving like a comet. Subscribe to follow the next update, because this story isn't over, and the universe may just be paying attention.